Hello everyone and welcome. Today we're going to talk about dynamics. First we're going to talk about transitional motion and rotational motion and gear ratio for better understand of the rotational systems and interpretation for the forces and motion. What is dynamics? Dynamics is the branch of mechanics that deals with the motion of bodies under the action of forces. So let's look at here. Here's some box. And when we put the external force from the left side, it will have linear acceleration A when its mass is m, F equals to ma, the famous Newton's second law. Let's say there's no friction on the surface, and rotational motion. Let's say there's some cylinder mounted on the axis. If we put torque m from maybe from the motor, it will have angular acceleration alpha when its inertia is I. So torque m equals to inertia I times angular acceleration alpha. So you may have heard of angular velocity or angular acceleration and even inertia, but I was pretty much forgot about the rotational system, so that's why I put the gear ratio for someone who also forgot. Let's say there's some spinning wheel. The point near the rim go farther than the point near the center. So the distance between the point and the center can be called radius. If the radius get bigger, the linear velocity v will also get bigger. Even the angular velocity omega is fixed because the angular velocity's definition is it rotates, how much rotates, how fast it rotates, even the same amount of time. So we can write down the angular velocity omega equals to v over r, and angular acceleration alpha equals to a over r. And what is inertia? Let's say there's some huge muddy dirt on this edge. It will be harder to move than when it's near to the center, the pivot. That's what we call inertia, the counterpart of mass. So now we learned about these simple laws, then how do we apply to the real world system? There's an interpretation, there's three steps. First, draw the free body diagram. These are the free body diagram. I drew the box and cylinder to simplify, for better understand, but it can be complex like robots or vehicles. And don't forget the force can be more than one. If there's like wall here, there will be force against the external forces, and there can be also gravity. There can be multiple forces on the one object or body. And then describe the differential equation like Newton's second law or rotational counterparts. You have to write down all these dynamics on the differential equation, which is the motion of equation of motion. Yeah, and then get the transfer function. Transfer function is output over input. So let's say there's some system, it will have complex dynamics, more than one. You have to write down all of them. You cannot even miss one. That will cause a huge error. So the transfer function, the output over input, is showing how the systems works, because the systems, they get input and they draw out the output. And after we get the transfer function, we can where the control engineering starts, we can put like controller to make them stable, like not, and get the value what we want, like to follow tracking the reference value. We can do this by using Laplace transform, which is a strong method, and let us get the transfer function much easier. Yeah, so we're gonna learn about this next chapter. So if you have any question or comments, feel free to leave them below. And thank you for watching.